Triceratops was a genus of herbivorous chasmosaurian ceratopsid dinosaur that first appeared during the late Maastrichtian stage of the late Cretaceous period, about 68 million years ago in what is now North America. It is one of the last known non-avian dinosaur genera, and became extinct in the Cretaceous-Paleogene extinction event 66 million years ago. The name Triceratops, which literally means three-horned face, is derived from the Greek words tri meaning three, keras meaning horn, and ps meaning face, bearing a large bony frill, three horns on the skull, and a large four-legged body, exhibiting convergent evolution with rhinoceroses and bovines. Triceratops is one of the most recognizable of all dinosaurs and the most well-known ceratopsid. It was also one of the largest, up to 8 meters, 26.2 feet, long and 9 metric tons, 9.9 short tons, in body mass. It shared the landscape with and was most likely preyed upon by Tyrannosaurus, though it is less certain that two adults did battle in the fanciful manner often depicted in museum displays and popular images. The functions of the frills and three distinctive facial horns on its head have long inspired debate. Traditionally, these have been viewed as defensive weapons against predators. More recent interpretations find it probable that these features were primarily used in species identification, courtship, and dominance display, much like the antlers and horns of modern ungulates. Triceratops was traditionally placed within the short-frilled ceratopsids, but modern cladistic studies show it to be a member of the Chasmosaurinae, which usually have long frills. Two species, T. horridus and T. prorsus, are considered valid today, from the 17 species that have ever been named. Research published in 2010 concluded that the contemporaneous Torosaurus, a ceratopsid long regarded as a separate genus, represents Triceratops in its mature form. This view has been disputed. Further data is needed to settle the debate. Triceratops has been documented by numerous remains collected since the genus was first described in 1889 by American paleontologist Othniel Charles Marsh. Specimens representing life stages from hatchling to adult have been found. As the archetypal ceratopsid, Triceratops is one of the most popular dinosaurs, and has been featured in film, postal stamps, and many other types of media. Triceratops is estimated to have reached about 7.9 to 9 meters, 25.9 to 29.5 feet, in length, 2.9 to 3.0 meters, 9.5 to 9.8 feet, in height, and 6.1 to 12.0 metric tons, 6.7 to 13.2 short tons, in body mass, but Gregory S. Paul suggested a lower length of estimate of 8 meters, 26 feet, and a lower body mass estimate of 9 metric tons, 9.9 short tons. The most distinctive feature is their large skull, among the largest of all land animals. The largest known skull, specimen MWC 7584, formerly BYU 12183, is estimated to have been 2.5 meters, 8.2 feet, in length when complete, and could reach almost a third of the length of the entire animal. A specimen of T. horridus named Kelsey measured 7.3 meters, 24 feet, long with a 2 meter, 6.5 feet, skull, stood about 2.3 meters, 7.5 feet, tall, and was estimated by the Black Hills Institute to weigh nearly 6 metric tons, 6.6 short tons. Like all chasmosaurines, Triceratops had a large skull relative to its body size. The front of the head was equipped with a large beak in front of the teeth. The core of the top beak was formed by a special rostral bone. Behind it, the premaxillae bones were located, embayed from behind by very large circular nostrils. In chasmosaurines, the premaxillae met on their midline in a complex bone plate, the rear edge of which was reinforced by the narial strut. From the base of this strut, a triangular process jutted out into the nostril. Triceratops differs from most relatives in that this process was hollowed out on the outer side. Behind the toothless premaxilla, the maxilla bore 36 to 40 tooth positions, in which 3 to 5 teeth per position were vertically stacked. The teeth were closely oppressed, forming a dental battery curving to the inside. The skull bore a single horn on the snout, above the nostrils. In Triceratops, The nose horn is sometimes recognizable as a separate ossification, the epinasal. The skull also featured a pair of brow, or supraorbital horns, approximately 1 meter, 3.3 feet, long, with one above each eye. The jugal bones pointed to below at the rear sides of the skull and were capped by separate epijugals. With Triceratops these were not particularly large and sometimes touched the quadratijugals. The bones of the skull roof were fused. By a folding of the frontal bones, a double skull roof was created. In Triceratops, some specimens show a fontanelle, an opening in the upper roof layer. 30. The cavity between the layers invaded the bone cores of the brow horns. At the rear of the skull, the outer squamosal bones and the inner parietal bones grew into a relatively short, bony frill, adorned with epichipitals in young specimens. These were low triangular processes on the frill edge, representing separate skin ossifications or osteoderms. Typically, with Triceratops specimens there are 2 epichipitals present on each parietal bone, with an additional central process on their border. Each squamosal bone had 5 processes. Most other ceratopsids had large parietal fenestrae, openings, in their frills, but those of Triceratops were noticeably solid. 33. Unless the genus Torosaurus represents mature Triceratops individuals. Under the frill, at the rear of the skull, a huge occipital condyle, up to 106 mm, 4.2 in diameter, connected the head to the neck. 30. The lower jaws were elongated and met at their tips in a shared epidentary bone, the core of the toothless lower beak. In the dentary bone, the tooth battery curved to the outside to meet the battery of the upper jaw. At the rear of the lower jaw, the articular bone was exceptionally wide, matching the general width of the jaw joint. T. horridus can be distinguished from T. prorsus by having a shallower snout. 26. The largest Triceratops skull ever found was discovered in 1992 and excavated in 2003 in Dawson County, Montana, in the Hell Creek Formation. It is a 66-million-year-old male Triceratops skull, 9.2 feet, 2.8 meters, long, 5.2 feet, 1.6 m, high and 4.6 feet, 1.4 m, wide and weighing over 1,300 pounds, 600 kilograms. It has been dubbed Dragon King and is understood to be the most expensive skull to ever trade privately. Chasmosaurians showed little variation in their postcranial skeleton. The skeleton of Triceratops is markedly robust. Both Triceratops species possessed a sturdy build, with strong limbs, short hands with 3 hooves each, and short feet with 4 hooves each. 36. The vertebral column consisted of 10 neck, 12 back, 10 sacral and about 45 tail vertebrae. The front neck vertebrae were fused into a syncervical. Traditionally, this was assumed to have incorporated the first 3 vertebrae, which would imply that the frontmost atlas was very large and sported a neural spine. Later interpretations revived an old hypothesis by John Bell Hatcher that at the very front a vestige of the real atlas can be observed, the syncervical then consisting of 4 vertebrae. The vertebral count mentioned is adjusted to this view. In Triceratops the neural spines of the neck are constant in height, instead of gradually sloping upwards. Another peculiarity is that the neck ribs only begin to lengthen with the 9th cervical vertebra. The rather short and high vertebrae of the back were in its middle region reinforced by ossified tendons running along the tops of the neural arches. The straight sacrum was long and adult individuals show a fusion of all sacral vertebrae. In Triceratops the first 4 and last 2 sacrals had transverse processes, connecting the vertebral column to the pelvis, that were fused at their distal ends. Sacrals 7 and 8 had longer processes, causing the sacrum to have an oval profile in top view. On top of the sacrum a neural plate was present formed by a fusion of the neural spines of the 2nd through 5th vertebrae. Triceratops had a large pelvis with a long ilium. The ischium was curved downwards. The foot was short with 4 functional toes. The phalangeal formula of the foot is 2-3-4-5-0. Close-up of pelvis of Triceratops specimen at the Oxford University Museum of Natural History. Although certainly quadrupedal, the posture of horned dinosaurs has long been the subject of some debate. Originally, it was believed that the front legs of the animal had to be sprawling at a considerable angle from the thorax in order to better bear the weight of the head. This stance can be seen in paintings by Charles Knight and Rudolf Zallinger. Ichnological evidence in the form of trackways from horned dinosaurs and recent reconstructions of skeletons, both physical and digital, seem to show that Triceratops and other ceratopsids maintained an upright stance during normal locomotion, with the elbows flexed to behind and slightly bowed out, in an intermediate state between fully upright and fully sprawling, comparable to the modern rhinoceros. The hands and forearms of Triceratops retained a fairly primitive structure compared to other quadrupedal dinosaurs such as pterophans and many sauropods. In those two groups, the forelimbs of quadrupedal species were usually rotated so that the hands faced forward with palms backward, pronated as the animals walked. Triceratops, like other ceratopsians and the related quadrupedal ornithopods, together forming the Theropoda, walked with most of their fingers pointing out and away from the body, the original condition for dinosaurs, also retained by bipedal forms like the theropod. In Triceratops, the weight of the body was carried by only the first 3 fingers of the hand, while digits 4 and 5 were vestigial and lacked claws or hooves. The phalangeal formula of the hand is 2-3-4-3-1, meaning that the first or innermost finger of the forelimb has 2 bones, the next has